I appreciate you stopping by to check out this episode of Vintage Audio Review. If you're an audiophile or somebody who's just into audio, you've probably either experienced tube rolling or have heard about tube rolling, which is basically swapping one brand of tubes for another brand of tubes, or maybe a slightly different variation of the tube with another variation of the tube, and hopefully achieving sonic bliss. I decided it would be kind of fun just to measure the performance using different tubes, and the guinea pig for doing this is the Freya Plus preamplifier, which uses 4 6S7 tubes, and so that kind of makes it easy to do swapping, 2 tubes for each channel. Now it does have a solid state tube that you can buy as a replacement for the vacuum tubes if you so desired. Shit sells those. I did not have those to test, but they do make them. Now, this preamplifier has the ability to run as a strictly passive preamplifier or a passive preamplifier with a buffered stage. Neither of those will give you gain. When you go to the tube stage, you do have gain. My little quirks about this before I say more is that the on-off switch is in the back. A lot of people have mentioned that and complain about that. And the other thing I don't like is it does not have tone controls. I am a big believer in tone controls just because of situations you need a little bit more bass, a little less bass, a little bit more treble, a little less treble. And if you're a purist that says you want it going straight through without hitting tone controls for the small amount that they usually add to your frequency response, you better have a perfect room and perfect ears to be able to hear those small differences caused by tone controls in a detent position. But anyway, that's just a gripe in general. So it makes a very nice preamp to do this test. As I said, the results might carry over to a power amp. Maybe one day I'll play around with power amp, but just needing 4 6S7 tubes makes it a lot easier to do the swapping. So that's kind of what we have going on with this. Now it does have a remote control. That is kind of nice to have. It sounds really good just with the tubes that came with it, or that I got it with from my good buddy Richard. I hooked it up to the Wilson Watt 3 Puppy 2s using the Carver M400A Cube amplifier, and it sounded really nice. I mean, as far as the sound, it sounds fine with tubes. But if you go to the passive state for the preamplifier with 0 dB gain, it's not enough to get loud to where I like. So, you know, that's why I like preamplifiers with gain. But it does have that option for you purists. So that's kind of what this thing's going to be about. We'll look at how it performs with different tube combinations. There's a lot of data, but I'm going to put chapter marks like I always do so you can just skip through it easily, and then at the end I'll kind of summarize some of the highlights of the data, and we'll go over those results at that point, kind of what all this testing showed. So that's kind of what this video is about, and now let's get into some of the data. I thought I would show how I use my tube tester, which is a B&K model 607. And I've got my 6SN7 here. This one is one of the Sylvanias. The load and the heater voltage are all set up. It has 2 selector positions. The first one is position number 1, and I'm going to go ahead and press the quality button. And then the meter is reading about 82 for position 1. Next, we go over to position 4, and I hit quality, and it's about 80. So I'm going to measure all the tubes and note those 2 readings, and I'll show what they are in the video at some point. Also, you can go in and determine if there's leakage for either of those positions, position 1, position 4, and there are no leakage. And then what you do is rotate the selector around and make sure that that short light does not stay on. It can go on momentarily, but you want it to be off. So that is what's involved with tube testing. For other tubes, you do different sockets or different lockouts, they're called, different loads, etc. But all the tubes I have will go through there, and I will show you what each of the tubes read. Here are the results from the tube measurement data. And let's start over here by just telling you the tubes we have. We have two Sylvania tubes, and those are old tubes. We have Tungsol tubes. They're Russian made, which are newer. We have the 68HC tubes, which are also Russian made and a newer tube. And then we have old stock RCA tubes. The selector 1 and selector 2 are the test positions, and the numbers in these two columns are the merit numbers. You'd like as high a merit number as you could get, and they're all between 78 to 82, so they're pretty close. The two leakage numbers, those are for the leakage test done in the appropriate selector position. You would like a leakage of 0. You can see that Sylvania tube number 2 has leakages of 58 and 13, and that is the most leaky of the tubes. The other tubes are not so bad. We do have a leakage of 9 for Sylvania number 1, and the Tungsol tube number 2 has 8, but for the most part, there's nothing as bad as 58. And we'll kind of see if that means anything when we get into performance. Right now, I've got a 1 kilohertz 2-volt RMS signal going into the balanced 1 input of the Freya Plus. Now, the tube configuration is that I have the Tungsol Russian tubes in the cathode follower output stage, which would be on the left, and I have the right tubes, or the differential gain stage tubes, are the Sylvanias. Now, I believe the left channel Sylvania, the one in yellow here, which has about 20 dB worse THD plus noise, is the one that had the leakage of 50 and 13. So what I'm going to do is swap the two tubes around and see if the right channel starts looking like that, just kind of to see what's happening with the tubes. I've now swapped the left and right channel voltage gain tubes, and these are the Sylvanias, and now the leaky tube is on the right channel, and indeed the THD plus noise is worse, the THD is worse, and you can see the SNR is worse. So that little bit of leakage, it was reading 58 and 13, depending on which of the portions of the tube were selected, does indeed affect the THD plus noise. Whether one would hear that, I don't know, but it is measurable. Here's the Freya Plus's frequency response from 20 Hz to 20 kilohertz with a 2-volt RMS signal applied to the balanced 1 input. In this case, we have the Tungsol tubes in the cathode follower output stages, and the Sylvania tubes are in the differential voltage gain stage positions. And there really isn't much difference between the left and right channel. In this case, the right channel has the tube with higher leakage in it. I'm not really sure that the leakage is causing this delta. This is pretty darn small. I mean, we're talking less than 1/10 of a dB between the left and right channel as far as the channel balance. So overall, I would say the frequency response looks great. Right now, I've got a 1 kilohertz 0 dBV signal going into the Freya Plus, still using the balanced input number 1. And what I'm going to do is increase the volume and see how much gain we can get before our signal starts looking like crap. Now, I should point out that we're at 0.25 dB, 0.24 dB of gain, and I chose that rather than go down 1 notch. If I change the volume control by 1 little detent, let's see what happens. So that's 1 detent, and I chose to go with a plus gain rather than a minus 0.38 gain. So I'm going to move it back to the plus gain side by 1 little click. Okay, so now we're at the 0.25 dB gain, I'll call it, position. And at this point, you don't see a big difference between the right and left channel. I mean, the THD plus noise is larger for the right channel, which has that leaky Sylvania tube, and we are still having the Sylvania tubes in the voltage gain section, and the Tungsol tubes are in the cathode follower section. So I'm going to start increasing this to where we start seeing a lot more distortion and noise coming up. So at 10 dB of gain, you can see that our noise went up, particularly for the right channel, and you can see the distortion for the right channel is higher, which makes sense because you can see the harmonics are higher. Now I'm going to increase the gain just a little bit more. So at 12.7 dB of gain, you can see our THD plus noise has gotten worse, and the distortion is still not too bad at this level, and the SNRs are still not bad. You can see that this noise has started coming up here for the right channel with that leaky tube. We'll go up just a little bit more. So here we've got just shy of 16 dB of gain, still not looking really bad. You can still see this noise on the leaky tube has gotten a little bit worse, but overall it's not too bad. And we're putting out a little over 6 volts, so we could probably still go up just a little bit more. So right now I have maxed out the Freya Plus's gain, which shows it at about 17 3/4 dB of gain. It still doesn't look so bad. I mean, it looks, you know, kind of bad with some of the harmonics, but overall it's you know, not bad for the left channel. If the right channel were looking the same, I would say it's pretty good. So overall, the THD looks good, and we can get, what, 7.7 volts out of this thing at full level. Now, if I increase my signal input, we obviously could get more out, but for right now, it's just kind of a little comparison to see how it works with these tubes, and then we'll switch the tubes around and see if it does any better. Here's the Freya Plus's frequency response from 20 hertz to 20 kilohertz with a 2-volt RMS signal applied to the balanced 1 input. And our tube situation is that the tungsol tubes are in the differential voltage gain stage, and the cathode follower tubes are the Sylvania tubes, with the right channel tube having the most leakage of any of the tubes. And both of the tungsol tubes had the same emissions. So the difference here is kind of what we saw when we looked at our THD plot. We saw the two channels had, maybe 0.2 of a dB, something like that, difference in gain. And that just happens to be the effect of using these tubes. When you look at the original tube frequency response, it was much better with the tube configuration. We had not more than 0.4 of a dB. And you can see here at the low end part of the band, we're down 6/7 of a dB here at the low frequency end, and at the high end we're a bit better actually than we were with the other tube. So swapping the tubes can definitely change your frequency response a little bit. And in case you were wondering what the harmonics look like, and this is for the case where the tungsol tubes are in the cathode follower spot and the Sylvania tubes are in the differential voltage gain spot, which would be the tubes on the right. And for this case, our right channel Sylvania tube is the leaky one. And you can kind of see that it has a greater harmonic level. And you saw that earlier in the THD plot, but you can see that our second or even harmonics are higher than the third, which is kind of what you get with tube stuff, but not always. And you can see that between the left channel and the right channel, the non-leaky left channel is definitely lower in harmonic level. And you saw that in the plot earlier. Right now, I've got a 1 kilohertz 2-volt RMS signal going into the balanced number 1 input of the Freya Plus. I swapped the tubes around such that the tungsol tubes are in the differential voltage gain position, and the Sylvania tubes are in the cathode follower stage. Now, the leaky Sylvania tube is still in the right channel position, and the slightly leaky tube, it wasn't very leaky. It had values of 1 and 8 for leakage for the tungsol, where the other tungsol had 0 for the leakage. So it's basically 0, but that is also in the right position. And you can see that compared to where we were with the tubes swapped when we started, our gain's just a little bit off. We were around 0.24 or 0.25 dB for the two channels here. We're off just a little bit between them than we were when we started with the other pair of tubes. The THD still looks pretty good. However, the right channel is a little bit more, and you can kind of see that from the plot here. And the THD plus noise is also worse for the right channel, and our SNRs are a bit better for both channels than they were in the other tube condition. So it looks like the leaky tube would probably do you a little bit better in the cathode follower stage. So we'll see what other things might be different. Right now we're looking at our standard THD SNR plot at 1 kilohertz with a 0 dBV or 1 volt RMS signal going into the balanced 1 input of the Freya Plus. The volume control is set to as close to 0 dB gain as I can get it, and our tube positions are the tungsol tube are in the differential voltage gain stage positions, and the Sylvania tubes are in the cathode follower output stage positions, with the leakier tube going into the right channel position. And you can kind of see that we have the second harmonic here for the right channel higher than the left channel, which you can see here as well in the THD plus noise. Now, the SNRs are around 80, and that's because I have 24 dB of attenuation on the analyzer set in. If I switch it over to 18 dB, this would improve by a lot, but I'm going to be increasing the volume control and hence the gain, and see how we do when we get a higher level of gain coming out of this, and see if we can max it out with still having reasonable success with these tubes. So I've maxed out the gain on the Freya Plus, and we're seeing about almost 18 dB of gain. Our SNRs still look pretty good, but the THD plus noise is not. And you can see the THD for the right channel, its percentage has gotten worse. And with this tube combination, we do not have as good a response, you can see, as we did with the other tube combination. So maybe the tungsol tubes are better in the cathode follower position is kind of what I'm seeing. Right now I've got two different pairs of tubes going in for the cathode follower tubes. They are Russian 6/8 HC tubes, and for the differential voltage gain tubes, they are older RCA 6 and 7s. And what you can tell is that it has almost identical gain. I'm able to get exactly 0 dB gain, let's say, whereas before I was getting about 1/4 of a dB gain depending on which tubes. And everything looks really nice. Of course, we've got our 1 kilohertz 2 volt RMS signal going into the balanced input. And if you compare the SNRs for the two channels, they're pretty close. Before they were one channel was a little bit better and one channel was a little bit worse with the other tube combo, but right off the bat things look pretty good. Their THD is pretty much the same. One channel is better. The left channel on this guy is better. We don't have any leaky tubes with this pair. Both of them had very little leakage. I think one had a leakage of 3. The 68 HCs had a small amount of leakage between 1 to 3, so that's pretty insignificant. And the older RCAs had no leakage. So far it's looking pretty good. And in case you were wondering what the harmonics look like for the 68 HC tubes in the cathode follower position and the RCA tubes in the differential voltage gain position, with the volume control set to give 0 dB of gain and 2 volts RMS going in. This is it. It looks better than the case where we had the tungsol and Sylvania tubes, and you can see that the harmonics are both balanced for both the left and right. Our second or even harmonic is indeed higher than the third or odd harmonic. Here is the Freya Plus's frequency response from 20 Hertz to 20 kilohertz with a 2 volt RMS signal going into the balanced 1 input. And the tube configuration is the 68 HCs are in the cathode follower positions and the RCA tubes are in the differential voltage gain positions. And if you compare this with the previous tube set, it looks pretty much the same. The channel balance is a little bit better with this guy. The first set of tubes with the leaky Sylvania tube had a bit of offset. As you remember, the right channel, which was leaky, was offset just a small amount, maybe like 0.05 dB, real small. But these guys are pretty much dead on top of each other, and the overall frequency response looks pretty much identical. Right now, I've got a 0 dBV 1 kilohertz signal going into the balanced 1 input of the Freya Plus. I've adjusted the volume control so that it's giving the maximum gain that it could. It's basically full clockwise. And it looks pretty good. The tube complement is the 68 HC tubes are in the cathode follower positions, and the RCA tubes are in the differential voltage gain positions. If you contrast this with the Sylvania tungsol tubes, you will see that the SNRs are a little worse for the two of them, and our gain is slightly less. I mean, a couple tenths of a dB. These are right around 17, we'll say 17.5. And the other tube combination was, I think, 17.6 to 17.8 dB of gain. So with the tube combination with the Sylvania tube, it had worse of a THD for the right channel, where here the maximum THD is 0.04%. So it looks better as far as THD, and the THD plus noise is definitely better with this combination of tubes in contrast with the other combination of tubes. Right now we've got a 1 kilohertz 2 volt RMS signal going into the balanced 1 input on the Freya Plus. The tube configuration is switched in that the 68 HC tubes are in the differential gain position and the RCA tubes are in the cathode follower position. And if you compare this to the case where the tubes were in reverse positions, you will see that the SNRs are a bit better. They were around 97, 98, 96, and now we're above 100. The THD plus noise, though, is a bit less. They were around minus 87 dB, and now they're, we'll say, 81, 82 dB. So that's a little bit different. The channel balance is just a little bit worse. We were at like plus or minus 0.03 dB, and here we're at best case plus or minus 0.09 dB. Still not a big change in the grand scheme of life. Our THD is a little bit worse here, but you're talking 0.0943% versus 0.0415% for the left channel, and the right channel is also not quite as good by a little bit, but it's trivial. So other than that, you also can see that our spurs here, we got some spurs, and those were not present with the tubes in the other positions, and we have some power supply kind of noise here that we didn't see before. And in case you're wondering what the harmonics look like, let's go ahead and bring those up. The harmonics look different than with the tubes in the other positions. In this case, you can see for the left channel, the even order or second harmonic is higher than the odd harmonic. For the left channel, however, the right channel even harmonic is lower than the right channel odd harmonic. So it's kind of got mixed results in that sense. Here is the frequency response from 20 hertz to 20 kilohertz with a 2 volt RMS signal going into the Freya Plus's channel 1 balanced input. And this is for the 68 HC tubes in the differential voltage gain position and the RCA tubes in the cathode follower positions. When you compare this with the frequency response with the tubes in the reverse positions, the overall frequency response looks pretty much the same, other than there's a little small amount of difference between the two channels as far as their balance. It's less than 0.05 dB, so it's very, very small. Here we have a 0 dBV or 1 volt RMS signal going into the balanced 1 input of the Freya Plus at 1 kilohertz. The tube configuration is such that the 68 HC tubes are in the differential voltage gain positions and the RCA tubes are in the cathode follower positions. I have the volume control set for maximum volume or gain, and if you compare this with the case where the tubes were in the reverse positions, this has about a tenth of a dB more, maybe 0.15 dB more depending on the channel. The SNRs are about the same for the right channel. The left channel's about 6 dB better. THDs for both channels are pretty much the same as they were. The THD plus noise for the right channel's a bit worse, about 6 dB worse, and the left channel is pretty close to the same. And you can kind of see the increased noise at lower frequencies on the right channel, which is why that number is higher than it was for the case where the tubes were swapped. We also have these harmonics here that you can see on the left channel. If I turn off the left channel, you don't see that, just on the left channel. So you do have those little harmonics there, sidebands. Once again, we have our THD SNR plot at 1 kilohertz with 2 volts RMS going into the balanced 1 input. The volume control has been adjusted to give as close to 0 dB gain as I could get. And as far as the tube configuration, I have a tungsol tube and a 6/8 HC tube in the differential voltage gain positions. And then I have an RCA tube and another 6/8 HC tube in the cathode follower positions. And the 6/8 HC tubes are not in the same channel. So I've got just a hodgepodge of the tubes here. And right off the bat, you can see that our gains are pretty well balanced, not bad. Also, our SNRs are pretty good. If you compare that to some of the other tube configurations as far as the SNR goes, it's pretty similar. The right channel, the THD, is up a bit, probably an order of magnitude than some of the other configurations. And you can kind of see the right channel here, this third harmonic, is a lot higher than the left channels. THD plus noise, we'll say at least minus 79 dB. And overall, it doesn't look too bad. Kind of surprised at how good it looks. We'll see what the frequency response looks like next. Here is the frequency response plot from 20 hertz to 20 kilohertz with a 2 volt RMS signal going into the balanced 1 input of the Freya Plus. And this is for the case where the tungsol and 68 HC tubes are in the differential voltage gain positions, and the RCA and another 68 HC tubes are in the cathode follower positions. If you compare this with one of the other more balanced tube configurations, the high end is improved. The high end frequency response is improved, but the low end frequency response is reversed. So in one case, it only had about 0.3 of a dB of loss. Here we're about 0.6 of a dB at 20 hertz, but the high end only had about 1/10 of a dB, and the other tube condition, it had about 0.4 of a dB. So better at the high end, worse at the low end, but still not too bad. Here's our standard THD SNR plot at 1 kilohertz with a 1 volt RMS signal or 0 dBV signal going into the balanced 1 input, and with the Freya Plus's volume control set to a maximum, which gives us about 17.6 dB of gain. SNR is pretty good, about 96 dB. The THD is decent, 0.34%, pretty good. And overall it looks not too bad. THD plus noise around minus 70 dB, we'll call it. And it doesn't look terribly different than some of the other conditions we saw at maximum gain. So with the tungsol and 68 HC tubes in the differential voltage gain position, and the RCA and 68 HC tubes in the cathode follower positions, this mismatch doesn't seem to make that much of a difference as far as the gains. It might be 1/10 or 2 of a dB higher than some of the other tube configurations, but overall it's not that much difference. And with the tubes all jumbled up and the volume control set to give 0 dB gain with a 2 volt RMS signal going into the balanced number 1 input, these are what our harmonics are looking like. You can see that our even or second harmonics are higher than the odd or third harmonics. The right channel is barely higher than the left channel. I've got a 1 kilohertz square wave going into the unbalanced input. I believe that is number 3 on the Freya Plus, and we're measuring at the unbalanced output. I'm just showing the left channel. The right channel is pretty much the same. The tube configuration for this trace over here on the left is that the tungsol tubes are in the cathode follower position, and the RCA tubes are in the differential voltage gain position. For this trace over here on the right, the 68 HC tubes are in the cathode follower position, and the RCA tubes are in the differential gain position. So you can see that our rise time of the signal coming out is 2 microseconds, and it's 2.12 microseconds with the other tube configuration. So there's not any difference for the selection of tubes as far as rise time goes. If we move the frequency of the square wave going in to 10 kilohertz, you can see that for the tube configuration with the tongue saw in the cathode follower and the RCA in the differential voltage gain position over here on the left, and on the right we have the 68 HC tubes in the cathode follower position and the RCA tubes in the differential voltage gain position. You can see there's a small difference in rise time. We went from 1.98 microseconds to 2.2 microseconds. So there seems to be just a small amount of difference, but it's really not significant in the grand scheme of things. So right now I've got a 1 kilohertz sine wave going into the unbalanced 3 input on the Freya Plus, and we're looking at the unbalanced output. This trace on the left is for the tube configuration with the 68 HC tubes in the cathode follower position and the RCA tubes in the differential voltage gain position, and the trace on the right is for the tongue saw tubes in the cathode follower position and the RCA tubes in the differential voltage gain position. There really is no difference in phase at 1 kilohertz between the two tube configurations. If I change the frequency to 10 kilohertz, we do see a slight phase change. However, there really is no difference between the two tube configurations. And in case you're wondering, this guy on the right is for the tongue saw in the cathode follower position and the RCA tubes in the differential voltage gain positions, and the one on the left is for the 68 HC tubes in the cathode follower position and the RCA tubes in the differential voltage gain position. This plot shows the Freya Plus's THD versus frequency for several different input signal levels. In this case, the voltage gain, the volume control, is set for about 0 dB. And we are using the tongue saw tubes as the cathode follower tubes, and the Sylvania tubes are in the voltage gain position. The right channel still has that leakier tube in it. And you can see that the THD is worse for that at the highest power level of 5 dBV. And even then, we're better than, we'll say, about 0.03%. Once we get to 100 hertz, we see there's a rise in THD that goes up to about 1% at 20 hertz. And this just shows how the THD changes versus frequency with this tube complement. Here is the Freya Plus's frequency response from 20 hertz to 20 kilohertz with the input signal going into the balanced 1 input from 20 hertz to 20 kilohertz. The volume control has been set for about 0 dB of gain, and we're just looking at what happens to the THD as we increase our power levels. We start off at minus 16 dBV input and go up to plus 5 dBV input. And it pretty much looks like it did before when the tubes were reversed. So here we have the tongue saw tubes in the voltage gain position and the Sylvania tubes in the cathode follower position. And the leaky tube is in the right channel as before. And overall, we're seeing kind of the same response that we did before. Once we get down to 100 hertz, it looks like we're better than 0.03. It looks like it was slightly a little bit better as far as the THD at 100 hertz, but we have this kind of slope. And I'm not so concerned about this increase in THD. I think that's more related to the analyzer and the step size I gave it. I may go back and rerun the frequency step size a bit smaller from 100 hertz to 200 hertz and see if it cleans this up, and if so, I will show that. I went ahead and repeated the THD versus frequency for several different power levels, and I narrowed my span to 10 hertz to about 200 hertz, and I took narrower step sizes like 10 hertz step increments over that range. And basically, if you compare the other one, it's a little bit more detailed view here, but it pretty much looks the same as far as the THD does at the lower frequency levels. Here is a plot showing the THD versus frequency for several different input signal power levels. We have 5 dBV as the maximum and minus 16 dBV as the minimum. Frequency span 20 Hz to 20 kilohertz. And this is with the 68 HC tubes in the cathode follower position and the RCA tubes in the differential voltage gain position. And if you compare this with the previous THD versus frequency graph for the Sylvania tubes and the tungsol tubes, it looks pretty much the same overall. Once you get to 100 hertz, you're down better than we'll say 0.304 dB. So it looks pretty much the same, and then you have a distortion as high as, we'll say, 1% at 20 hertz. Here's the Freya Plus's THD versus frequency for several different input signal levels, going from minus 16 dBV to plus 5 dBV. The volume control has been set to give 0 dB gain, and this is for the tubes in a bunch of different positions. We have a tungsol and a 68 HC tube in the differential voltage gain positions, and we have another 68 HC and an RCA tube in the cathode follower position. So if you compare this with other tests for THD versus frequency, you see basically the same thing. This has a little bit of oddness right here at this particular frequency range, but it's still better than 0.01%, and it kind of still looks like the other THD versus frequencies did. So it doesn't look like having all these different tubes in different positions affects much as far as the THD versus frequency when comparing it with the other conditions for this Freya preamplifier. I was curious how another preamplifier performed for the same test conditions, and that is the THD versus frequency and input signal level with the volume control set for 0 dB gain. And so I pulled out the Carver C1. Its plot is here, and here is the Freya Plus with the 68 HC tubes in the cathode follower position and the RCA tubes in the differential voltage gain positions. You've already seen this plot. As you can see, our maximum THD is right around, we'll say 0.9% here at 20 hertz. And for the Carver, we're down about 0.3% at 20 hertz. And when we get to 20 kilohertz, it is about 0.00, maybe 7-8% for the Carver worst case, and we're about 0.00, we'll say 2% here at 20 kilohertz. So a little bit better for the Carver at both ends. And at about 100 hertz for the Carver, we're at 0.01% THD, whereas for the Freya Plus, we're at maybe 0.0034%, depending on the input signal level over here at 100 hertz. So the Carver definitely performs better as far as the THD versus input signal level. Overall, this is kind of what they look like, and this is what the Carver looks like. I summarized the performance of the different tube combinations in this chart here. This column right here is for the tube configurations, and I kind of color-coded them for each of the different tube configurations. And then, of course, we have the different performance data up here. And it has pretty much everything, except I didn't show the THD plus noise. So, for instance, right here we have the Sylvania tubes in the differential voltage gain position and the tungsol tubes in the cathode follower positions. And the right Sylvania tube is the leaky one. And you can see the SNR for the leaky tube is the lowest when the leaky tube is in the right position compared to the left position. And you can also see that our THDs are a little bit worse with the leaky tube. And the gains are pretty much the same regardless. The leaky tube didn't really affect the gain. The frequency response at 20 hertz, we're down 0.3 dB, and at 20 kilohertz, 0.4 dB. And with the volume control set to max, the most gain we're going to get is about 17.75 dB. Now here we swap the tubes around, and the Sylvania tubes are in the cathode follower position and the Tungsol tubes are in the differential voltage gain position. Still the right tube is the leaky tube. You can see that with the Tungsol tube in the differential voltage gain positions, our SNRs are a bit better, and having a leaky tube in the cathode follower position didn't really make a big difference. And our distortion pretty much stayed the same. Gains varied a little bit more with the tubes in that position. Not a lot more, a tenth of a dB maybe. And you can see the frequency response changed a little bit. It got better in the high end of the band and a little bit worse in the low end of the band, but only worst case would be what, 0.3 of a dB. And our gains overall stayed the same, the max gains. Here we have the RCA tubes in the differential voltage gain position and the 6/8 HC tubes in the cathode follower position. The SNRs are right around 97 or so, so it's a little bit better than up here. Distortion for both of them is pretty good, 0.0034%. And you can see that with the volume control set, I was able to get close to 0 dB of gain, which is what you're shooting for. And the frequency response is down about the same amount at both ends of the band. The max gain is a little less, 17.47 versus 17.75, something like that. So it's really only maybe 0.3 of a dB different in the max gain with those tubes in this configuration. And then if you flop over, so the 68 HCs in the differential voltage gain position and the RCA tubes in the cathode follower position, you can see that our SNRs improve quite a bit. Our THD also is looking pretty good there. The gains flopped a little bit. It got a little worse. I mean, 0.07 dB, 8 dB, something like that. Not too much difference in the grand scheme of things. The low frequency response was down 0.7 of a dB, so that's probably the lowest of the whole column. And then at 20 kilohertz, we're only down 0.2 of a dB. And the max gain's right around 17.6 dB. If we swap the tubes, so we have kind of a hodgepodge of tubes. So here we have the 68 HC and Tungsol tubes in differential voltage gain position, and then we have a 68 HC and an RCA tube in the cathode follower positions. Now the 68 HCs are in different channels. One's in the right channel, one's in the left channel. And you can see that our SNRs are still pretty good. Our THD is still pretty good. The gain is now, with the volume control set to as close to 0 dB as I could get it. The best I could do is 0.14 dB, 15 dB. And we have 0.6 of a dB loss at the low end of the band and 0.1 dB loss at the high end of the band. And our gains are still right around 17.06264. So it's really not so bad when I have all the tubes in different spots. I mean, it's definitely not the worst case of any of these, and it actually overall looks pretty good. There's a few things I wanted to mention, and the first was that, to the best of my knowledge, none of these tubes were purchased as matched pairs, which would mean that they would have gone through extra screening to optimize the characteristics of the tubes to each other. So as far as I know, none of these were matched pairs of tubes. Also, at least the Tungsol, the RCA, and Sylvania tubes have all been used a lot. I'm not so sure how much use the 68 HC tubes have gotten, but prior to my data collection, I let the Freya Plus run for at least a half an hour. Now the Freya Plus has a 45 or 50 second turn-on delay, so when you power it on, if you selected the tube operation of the Freya Plus, it waits 45 to 50 seconds for the tubes to stabilize before it will allow any signal to go to the output. So it kind of has a built-in warm-up, but I went beyond that for my measurements. So that's kind of one of the points. As far as listening to the different tube combinations. With the built-in delay of the Freya Plus, there's a delay of removing a tube so that it's cooled down enough. I guess you could wear gloves, but you should let the piece of gear operate for at least 10 to 15 minutes. And to be honest, as you saw from the data, there really isn't much difference between whatever set of tube that you had in there or when you put just a hodgepodge of tubes in different places. The differences are measurable, but I don't really think you're going to hear much difference when you're talking a couple tenths of a dB here or there, or just a small percentage difference. And even the SNRs with the leaky tube, you're not going to hear something that has a 92 or 3 dB SNR versus a 100 dB SNR. I think 99% of the population would not hear that difference. So I'm not sure there would be much difference in the tubes, at least from what I saw from this data. Maybe your results would vary. So if you have the ability to measure a tube to make sure it's not leaky, I mean, you did see a performance difference with the leaky tube, at least mainly with the SNR, and depending on the position, that same tube in the cathode follower didn't really exhibit any bad SNR. So it kind of depends on what position that leaky tube is in. And most likely you're not going to have the ability to measure your tubes with a tube tester, or be able to measure them with an analyzer once you had them in. To me, that's the best way to do it if you want to at least start off with a good matching between the channels. Also, on the chart that I just showed, the gain column for left and right, what that means is I tried to adjust the volume control to get to as close to 0 dB as I could, and those numbers reflect that. So with the volume control pretty much in the same position, the gain varied a little bit, and by a little bit, 2-3 of a dB, I think, worst case. So that's kind of what that meant. And then you saw the max gain I could get out, and once again, things only varied by, I think, not more than 0.3 of a dB overall. So, and if you can hear 0.3 of a dB one way or another, that's pretty impressive. So anyway, that's kind of just my take on this. If you had a power amp and you were swapping out the output tubes, it might have a larger effect. Maybe one day I will try that with my MacKit 30 power amplifiers or monoblock amp. So maybe one day I will do that if there's enough interest in it. And there might be more of a difference with output tubes, especially if you go to a slightly different type that would still work. But we'll leave that for another video, and we'll see what you guys think. So that's kind of my take on it overall. I think the tube rolling, if that floats your boat and you want to do it, by all means do it. As far as what I'm seeing, it really doesn't make that much difference, at least in the Freya Plus preamplifier. So once again, if you liked the video, thumbs up. If you have comments that you would like to make, please leave them and I will reply to them. And if you have not subscribed to the channel, please do so. That's the only thing I kind of ask so that the channel will grow. So once again, I thank you for watching, and until next time, I hope you have a great day or night.